everybody. Today we continue to learn the solubility of precipitate. In the last class, we have studied the solubility calculation of 1:1 and m/n precipitate under ideal conditions. For 1:1 precipitate, the solubility S is calculated as. For m/n precipitate, the solubility S is calculated as. These formulas can only be used in the absence of side reactions. In actual situations, precipitation equilibrium will be more complicated and easily affected by side reaction, such as the hydrolysis effect of M, complexation effect, acid effect, and coexisting ion effect, and so on. Therefore, there are some other ionic forms in the solution after the precipitated dissolution, in addition to the forms of crystalline ions or molecule or ion pairs. For example, in the saturated solution of silver chloride, besides silver chloride and a silver chloride molecule, there are also silver chloride 2 and silver chloride 3 forms. So the solubility of the precipitate silver chloride is no longer the equilibrium concentration of the ion silver or chloride, but the sum of all equilibrium concentrations of different forms of silver or those of chloride. The sum of the concentration of all forms of metal ions is expressed as M', while the sum of the concentration of all types of salt anions is expressed as A'. Therefore, the solubility of m/n precipitate can be expressed as. In other words, the calculation of solubility is converted to the calculation of M' or A'. So, how to figure out these two parameters? To calculate M' or A', we still need to resort to the concept of solubility product. In practice, the solubility product of m/n precipitate Ksp is expressed as, and according to the calculation of the secondary reaction coefficient, M and A can be replaced by the expressions of M' and A'. Finally, Ksp can be expressed as a following equation. In this formula, M', A', is given a new definition, that is, conditional solubility product, and is represented by the symbol Ksp'. Then we can get the equation of conditional solubility product. And for m/n precipitate, therefore, in practice, the solubility S of precipitate is equal to, compared with the solubility under ideal conditions, it can demonstrate that when there are secondary reactions, in other words, the solubility in the presence of secondary reactions is greater than that in the absence of secondary reactions, which is consistent with the actual situation. That's a calculation of the precipitate solubility under ideal condition and in the presence of secondary reactions. After this course, please conclude the differences and connections between solubility product, activity product, and conditional solubility product. That's all for today. Thank you for joining us.